Imagine a place in space where gravity is so strong that nothing, not even light, can escape. A black hole. These cosmic ghosts reveal themselves only by their pull on nearby stars and gas, swirling like water down a drain. We can't see the black hole itself, only its effects. Black holes come in many sizes, from a few times the mass of our sun to supermassive giants millions or billions of times heavier. These monsters lurk at the centers of most galaxies, including our own Milky Way, shaping the cosmos with their gravity. Understanding black holes is key to understanding how galaxies and the universe formed. For years, our view was blurry. We thought black holes started small and grew slowly over billions of years, feeding on gas, dust, and sometimes merging with others. But to truly understand their origins, we needed to look back in time, to the universe's earliest days. Black holes hold clues to the universe's birth and evolution. They are the gatekeepers of cosmic history. Unlocking their secrets required a new kind of telescope, one powerful enough to see the invisible. We needed to peer into the darkness and shed light on the universe's greatest mystery. Where did we come from? How did the universe transform from chaos to the star-filled expanse we see today? Black holes are a crucial piece of that puzzle. To solve it, we had to invent a way to look further and deeper than ever before. Only then could we hope to answer the biggest questions about our cosmic origins. And that's where our story truly begins. To unlock the secrets of the first black holes, we needed a revolutionary tool, the James Webb Space Telescope, or JWST. With its giant gold-plated mirror, JWST is the most powerful space observatory ever built. Its superpower? Seeing the universe in infrared light, letting us peer through cosmic dust and glimpse the ancient past. As the universe expands, light from the earliest stars and galaxies stretches into infrared, invisible to our eyes, but not to JWST. Hubble gave us stunning images, but JWST was designed to catch this ancient stretched light. Launched in 2021, JWST unfolded its mirror far from Earth and began its mission to look back billions of years. Scientists pointed it at seemingly empty patches of sky, searching for the first galaxies, the first stars, and the first black holes. JWST acts as a time machine. When it looks at a galaxy 13 billion light-years away, it sees it as it was 13 billion years ago. For the first time, we can watch the cosmic dawn unfold. We can see the building blocks of our own galaxy coming together. This incredible power has already revealed shocking discoveries lurking in the dark. Each new image is a window into the universe's earliest moments. With JWST, we're not just looking at space, we're looking back in time. The hunt for the universe's first black holes had truly begun, and what JWST found would change everything. JWST's powerful vision sent back images from the edge of time, and what it found stunned scientists. It discovered black holes that shouldn't exist so early in the universe. One, called QSO-1, appeared just 700 million years after the Big Bang, a supermassive black hole 10 million times the mass of our Sun, inside a tiny primitive galaxy. In today's galaxies, central black holes are a tiny fraction of the galaxy's mass, but QSO-1 made up a whopping 10%. It was like finding a watermelon inside a cherry pie. The galaxy itself was young, with few heavy elements, meaning not many stars had formed yet. Then came LID 568, another supermassive black hole, seen 1.5 billion years after the Big Bang. LID 568 was devouring gas and dust at a rate 40 times faster than scientists thought possible, shattering the so-called Eddington limit. These discoveries were more than cosmic oddities. They were clues that something was wrong with our understanding. These black holes were too big, too early, and growing too fast. The slow growth model couldn't explain them. There simply wasn't enough time since the Big Bang. It was clear, our story of the cosmos was missing a crucial chapter. JWST had revealed a cosmic mystery that demanded a new explanation. The universe's first black holes were rewriting the rules. Scientists had to rethink everything they thought they knew. The search for answers was on, and the next discovery would be even stranger. In July 2025, JWST captured an image that took everyone's breath away: the cosmic owl. Two glowing rings of stars, like giant eyes, marked the collision of two young galaxies 11 billion light-years away. At the center of each eye was a supermassive black hole, each over 10 million times the mass of our sun, furiously feeding on gas and dust. A bridge of gas and newborn stars formed a beak, completing the owl-like appearance. This was more than a beautiful image. It was a natural laboratory. Scientists could watch galaxy collisions, black hole growth, and star formation all at once. The cosmic owl showed how galaxy mergers could rapidly feed black holes, helping them grow fast in the early universe. But it also deepened the mystery. Some black holes, like QSO-1, grew massive without major collisions or many stars. The cosmic owl was a vital clue, but not the whole answer. The early universe was more complex than anyone imagined, and the puzzle of the first black holes was far from solved. The discoveries of QSO-1, Lid 568, and the cosmic owl left scientists with a cosmic puzzle. It was like finding a fully grown tree in a pot just planted yesterday. The traditional theory said supermassive black holes grew slowly from the remnants of massive stars over billions of years. But JWST found black holes that were too big, too soon, in galaxies with few stars and little time to grow. Our old models couldn't keep up. When observations clash with theory, science is on the verge of a breakthrough. The existence of these ancient monsters forced scientists back to the drawing board. What if supermassive black holes didn't start small? What if they were born big? Faced with impossible black holes, scientists proposed a bold new idea: primordial black holes. Instead of forming from dying stars, these black holes could have formed in the universe's first moments, from ultra-dense patches collapsing under their own gravity. Some primordial black holes could have started out hundreds or thousands of times the mass of our sun, born as heavy seeds. As the universe cooled, these black holes would have been ready to feed, pulling in gas and growing rapidly. This theory fits JWST's evidence. A massive black hole could form first, then attract gas to build a galaxy around it. It flips the old story: black holes as the architects, not just the residents of galaxies. Instead of galaxies forming black holes, primordial black holes could have seeded the first galaxies. The universe's earliest structures may have been built around these dark giants. The rulebook was being rewritten, and a new cosmic story was taking shape. The idea that primordial black holes seeded galaxies is a revolutionary shift. Instead of galaxies creating black holes may have created galaxies. Imagine building a snowman. The old theory started with a big ball of snow, the galaxy, and added a pebble, the black hole. The new theory starts with a heavy rock, the primordial black hole, and packs snow around it. This explains why we see oversized black holes in small young galaxies. These black holes didn't need stars to form, they were relics from the Big Bang itself. If true, black holes are not just cosmic destroyers, they're creators, the first chapter in the life of a galaxy. The blueprint for today's galaxies may have been set by these mysterious seeds. The universe's grand design could trace back to the very first second of existence. Proving primordial black holes exist would reshape our entire story of the universe. It would link today's galaxies to quantum fluctuations from the first instant after the Big Bang. This new story could even help solve the mystery of dark matter, the invisible mass making up most of the universe. What if dark matter is just a vast population of primordial black holes, invisible but heavy? JWST's discoveries make this idea more plausible than ever. Suddenly, two of cosmology's biggest puzzles, the origin of supermassive black holes and the nature of dark matter, might have a single solution. These discoveries matter to everyone. They're about our ultimate origins. Understanding the first black holes and galaxies is the next step in tracing our own cosmic history. The light JWST captures is more than data. It's the story of how the universe became what it is today. And black holes may have been main characters from the very start. The James Webb Space Telescope's discoveries are just the beginning. Scientists are now racing to find even earlier, more distant black holes, perhaps catching a primordial black hole before it builds a galaxy. They'll use deep sky surveys and gravitational lensing to spot the faintest, most ancient objects. On Earth, new computer simulations will test these bold ideas. We're living through a revolution in our understanding of the cosmos. Thanks to JWST, we're not just guessing about the universe's beginnings, we're seeing them. The universe is slowly giving up its oldest secrets, and we're here to listen, to learn, and to wonder at the magnificent story it has to tell.